Hello and welcome back to our channel. Today we have a very special topic to discuss, that is AKS Networking. We are excited to have our expert here to guide us through the ins and outs of AKS Networking, including the best practices, challenges, and everything in between. So, if you're looking to improve your networking skills or just curious about AKS Networking, then stick around and enjoy the session.
Hey there, welcome back. This is Atul from team K21Academy, and in this video or in this lesson, we are going to talk about networking in Kubernetes as well as Azure Kubernetes Service. Now, this is a high-level networking where you have networking traffic coming from internal within your Kubernetes cluster or incoming direct traffic and incoming non-direct traffic. And it might sound confusing here right now in a minute. And we'll also cover or talk about the Kubernetes networking. But before that, let me explain you what I wanted to, or what is the challenge or the problem this networking solve. So this is a diagram where you have two different worker nodes, worker node 1 and worker node 2, where you have two different applications. Application 1, which is Nginx, which is a web server type, which is running on a pod A in node 1. And then you have a second application which is running on pod 2 on worker node 2. Which is a Redis, which is a caching request. So web server will receive the request and forward it to the caching software, which in turn might forward it to the application server, which in turn might forward it to the database server. So how an application running on pod A can talk to the application running in pod B, or you have pod A and which is a Nginx server, web server, and you want to connect to this Nginx service from an external source, which is maybe from the internet, you have an application coming, or how this communication happens. That's the challenge that networking solves. So let's begin with, first of all, some basic concepts about networking, and then we'll talk about this. So as I said, I'll come back to this in a minute once we explain the basic networking concept so that you understand what does cluster IP means, what is node port means, and what is AKS node, which is a Azure Kubernetes Service node or a worker node means. And eventually, ultimately, we want to reach out to the pods or applications running on those pods. And there are different ways to go. You can directly go to the AKS node, which is Kubernetes node, or you can go via the load balancer and so on. We'll come back to this in a minute. But first, let's understand the Kubernetes networking. So what Kubernetes networking addresses is, or it solves the challenge of some of the questions like how do container to container communication happens within a pod. So as I said, in a pod, you can have usually one container, or you might also have multiple containers running inside a pod. So if there are two containers running within a pod, how they talk to each other. Or a pod running in node 1 talk to the pod in running in the same host. Or pod running on one worker node can come, how it can communicate to pod running on a second worker node within a cluster. Or there's a concept of service. I'll explain that in a minute, what that service is. It's not a web service, or it's not the service that we covered or I briefly touched base at the start, but it's the service which is basically an endpoint given to the client to access the application running on a pod. So how does pod talks to the service within a cluster, or how anyone externally, which is coming from internet, can talk to the pod using the service. We'll talk. These are the kind of some of the common questions that covers, and I'll cover service in the next slide. But for the time being, these are some of the communication that you need to think about. And hence, in order for Kubernetes networking to meet, Kubernetes exposes and asks all the different vendors, open source vendors, to donate or to tell about the networking or do the networking, but it gives mandate these basic requirement to all those who provide networking facility or networking plugin or networking feature for Kubernetes and say all pods should be able to talk to other pod without any NAT, which is a network address translation. This network address translation is a way to say that, for example, I'm coming to you and then you want to talk to your family member. You decide internally how you want to talk to your family member, but I talk to you and then you do that netting, network address translation, and you talk to, for example, your kid or your spouse and so on. So first thing is that if I'm a pod and you are a pod and your family member is a pod, I and your family member should be able to talk to each other directly without any network address translation. So all pods should be able to talk to each other without on the IP addresses without any network address translation. Similarly, all nodes or the host can talk to pods without any network address translation. So let's suppose I'm a pod 1 running on a host 1 should be able to talk to the node 2 or pod running on node 2 without any network address translation. And third requirement is that if a pod is able to see an IP address, whatever itself, the same IP address should be visible to any other pod member outside that particular host or node. So in a nutshell, in a simple terms, to put it in a very simple terms, each pod ideally should get its own IP address in Kubernetes. That's the concept. So when you define a pod, it will get its own IP address, dedicated IP address. That's the networking requirement is. Now, apart from this service, which I'm going to cover that in the next section, which you'll understand what this service means, I'll briefly touch base a concept of Ingress controller. And maybe in our main Kubernetes training program, we cover a separate dedicated module about Ingress controller in that. So what happens is there are two type of traffic that can come. And this is based on this left-hand side screen that you see, which is a open standard for a networking or OSI model, which we say 7 layers. So the data can move. Transport layer number 4, which says the data is moving using TCP protocol or UDP protocol over SSL or TLS. So that at network level. So our load balancers typically support layer 4 networking, which is transport layer security. It doesn't know about what is the application saying. It simply receives the request, and on a TCP UDP pay layer, typically TCP, it forward request on that. So that's one. Or you can also configure a application layer or application level based load balancers, or we call Ingress controller, which runs at a layer 7 layer where it's on HTTP protocol or HTTPS protocol. So application layer you can define. So any request coming, you can either put a load balancer, which is a layer 4 type of network model, or Ingress controller, which is a layer 7 model for request coming from internet to the Kubernetes. And that probably I'll cover towards, and that's another concept you need to understand. But what is service? That's the point you need to understand, and then I'll come back to this slide again. So let's first understand the concept of service in Kubernetes. And this is not the service which we mentioned that you have microservices. It's not that, but different. And I'll explain that here. So when typically a client makes a call, they can connect to the pod IP because pod will have its own IP, and pod is where application is deployed. So if you try to do or connect to the pod IP directly on and try to access application, what happens is if that pod dies, and which is quite common, your pod might die and a new pod might come up, or you might have be running multiple instances of that pod. That pod can spin off into another virtual machine or another worker node or on the same worker node, and then IP will change. And that means client will have to change IP again, which is not a very convenient way to do things. And hence, there is a concept of service in Kubernetes where what you do is client will always make a call to the service, or service will have its own IP address and a port number. So client will make a call to service, and service in turn will forward it to the pod. And how it does that is using something called as label. I'll explain that as in a minute. So advantage of using this approach is that the IP address or the service IP, that stays always static unless you go and manually ask Kubernetes to change that or drop that service and create again that service. Otherwise, it'll stay the same. Now, the service to pod communication is or interaction is dynamic using labels. So what is a label? So when you create a pod, you can also create in the pod definition, you can say you can assign a label. So in this case, if you see here on left hand side, you have a label of prod and v1. So you have a label called env is equal to prod and version is equal to v1. And when you create a pod, you define these label. And in service, you say my labels selected are where environment is equal to production and version is equal to v1, then forward request to all these pods. Now, if this pod has, for example, the pod on the left has an IP address like .1, and if this pod goes down and it comes up again on another host, but with the IP address, for example, 5 or 4. Now, the environment is equal to prod is same and version equal to v1 is same. It's just the IP has changed. So the service now knows that, oh, I need to forward request to this because it's a same label, which is env is equal to prod and version is equal to v1. So client will never make a change. The service will dynamically register this new pod because the labels are matching. And hence, even though IP address change, because the labels have say same, the service will automatically forward a request to this backend pods. So what you can do is, like in this example here on right hand side, you have env is equal to prod and version equal to v1. Now these two pods have these two labels: prod is equal to env is equal to prod and version is equal to v1, and both these two pods on the right hand side. So service will forward request to these pods. The first pod has only one service, or sorry, label, which is env is equal to prod. So it will not forward request to the first one because service is expecting, or service will forward request to only the pod that has both of these labels, and hence it will forward it to this here. So this is the concept about the service. Now, service, when you define, there are four different type of service you can define. So when you're constructing a service through YAML file, you're actually going to create and say, what is my service type, which could be a cluster IP, which could be a node port IP, which could be a load balancer, or it could be a service type, an external name. Now, what is a cluster IP is basically when you create a service, it'll define a cluster IP, and all the pods which are part of this cluster will be able to communicate with this cluster IP without any additional configuration. So we simply say that pod A or pod B or pod C, within, as long as they're part of the same cluster, they simply connect to this cluster IP and the port number that this cluster IP is listening on, and that cluster IP service will automatically forward it to the respective pod running listening on a specific port number. So that's service or cluster IP. So cluster IP is useful when the communication is internal within the cluster from pod to pod. If you have a service, or if you have the request coming from outside the cluster, in that case, you will define a node port type, which means that on top of the cluster IP, it will be a node port. So you will have wherever a particular port, a node IP and the port number. Combination of these two will be defined in a service. So client will make a call, or client will request a node port number or a node port type service. So in that service, you will have a request going to a node with a specific port number that will do the mapping to the service. I'll explain that in a minute by going when I look or explain this here, what does or how this communication happens in a node port if a request is coming from externally. But assume there's a second type of service which is of type node port number. And third is a load balancer, where you or Microsoft Azure will create, or you will have an external load balancer. And that load balancer, and you define, when you define a service and say it's of type load balancer, and whatever is the IP address of that load balancer, your service will assign to that load balancer. And that load balancer will in turn forward request to the specific nodes and the port number on which that pod is listening. And the fourth one is external name. It's basically for where you have a DNS entry which is outside the cluster, and you're pointing to that DNS name entry, and which is then forwarding request. That particular entry, wherever you have that domain name service entry, that's forwarding request to your pods. So these are the four different type of service. So when you're defining the service, you will say what type of service is it? Is it a cluster IP, node port, load balancer, or external name? Now, just to recap on Kubernetes in Azure or Kubernetes in generic, the cluster IP is used for internal communication only when you want to reach within the cluster. Node port is if you want to go or come from this node port exposes your service to outside the cluster. So if you're coming from, example, internet or intranet, but not part of the cluster, request is not coming from a cluster member, then in that case, you will use node port. Or if you want to expose your service to a load balancer external on a cloud load balancer, this is when you will pick up the load balancer. Or external name is it maps the service to the content of an external name, which could be for any DNS name written by CNAME within your domain name server. So when I'm defining a service, I'm saying service type, and this is where I'm defining here and saying node port. or cluster IP or a load balancer or external name. And then this is where I'm selecting the app, which is basically my labels, and say app is equal to my app or environment is equal to production and so on. So this is a service type. Now, if you're defining a service type of load balancer in Azure, make sure that you have a load balancer already created. And then that load balancer should be, depending on it's a public load balancer, it could be a private load balancer. Public load balancer means it's exposed onto the internet and you can access it from the internet. Private load balancer is accessible within the Azure network only. You can't access it from outside Azure. Now you specify you get your cluster. So in the Azure, there's a concept of a resource group. So make sure that a resource group is created. So the load balancer should be in the same resource group as your Kubernetes cluster is. Again, we'll cover that maybe in future when we look at the load balancer or define Kubernetes cluster. Now, to explain you, the two common types is of service are cluster IP and the node port IP. So the cluster IP is, as I said, you have a pod which is running an application, for example, Nginx here. And you might be running multiple instances of this Nginx application on a different pods. And all those pods which are running Nginx service or Nginx application, they are exposed via a service whose IP is 10.10.10.4:80. So that's the cluster IP you're assigning. And similarly, if you have an application 2, which is a Redis application, and that will also have a service exposed, which is a cluster IP, and that cluster IP is 10.10.10.3:80. So if this application needs to talk to this service, they're going to communicate over this service 10.10.9.3.80. So the pod will hit request to this. The minute the pod A says, I want to connect to this service 10.10.9.2, the pod will connect to this service here onto 10.10.9.3, this service, going out and making a request to the service here. This service will talk to this service here, and that service will forward request to this pod B here. So this is cluster IP. Now, something similar to that, you have a node port where, let's suppose you have a application. Now this Nginx application, you want to expose it to the external world. So you will have a pod and this will be a service exposed, and the service IP is 10.10.10.4:80. This is the cluster service address. So this 10.10.10.4 IP is the pod IP, and then you've exposed it via the service which is 10.10.9.3:80. Now this service is running on a node, and that node will be having a port number. You assign a node port number which is 32050 for this IP, whatever is the node IP. So in this case, you'll be external world, you'll be connecting to 32050 on this node. Node will forward request to this service, and then in turn will go to this pod application running on this pod. So this is the difference between these two cluster port. In a nutshell, if you want to expose to the external, then you use node port number or the load balancer. If you want to keep cluster communication internal, then use cluster IP communication. So based on these two, Kubernetes has two type of networking. When we create a Kubernetes instance, I'm going to show you that, or let me first show you onto the Kubernetes cluster. So if you see, I'm on the Azure portal, and from here you just search for Kubernetes, and you will see this first Kubernetes service. Click on this and click on from drop down add Kubernetes cluster. This is how you create a Kubernetes cluster or Azure Kubernetes service from the portal. So inside that, if you see on, there'll be a networking, and here you select basic networking. And when you select basic networking, all you need is a DNS prefix and a load balancer, whether you want a load balancer will be what kind of a load balancer, and then whether network is private or public. Private cluster with is enabled, or and then third one is network policy. I'm going to cover that network policy a little bit later. But the main important thing I wanted to show you was that networking configuration is basic or advanced. And when you select the advanced, you select the virtual network in which you're going to define this Kubernetes cluster, and then the service which we discussed, the addresses. So each service that you define, it will have an IP address, and that IP address will be picked up from this CIDR range, which is 10.0.0.016. And then Kubernetes itself will create a DNS service. That IP address will be this. And there'll be a bridge address that you need to define. So this Docker bridge address is basically the network bridge that containers need to communicate. I'm going to show you in a minute this on the screen. So advanced has a lot more configuration. So this is what I wanted to show you, that when you define networking, there are basic or advanced networking you can define in Azure Kubernetes. So coming back to this slide where we looked at earlier, the cluster IP and node port, as I said in Azure Kubernetes Service, there are two types of networking you can define. One is the simple networking, and when you define the simple networking, behind the scene, Azure Kubernetes is using KubeNet as a network plugin. So when you select a simple networking, it uses this KubeNet, which is a type of network plugin. Basic configuration it defines with KubeNet. So in this definition, a node get an IP address from the Azure virtual subnet. So this is a network. You define a virtual network. Inside that, you create a subnet, and the machines will get an IP address from this subnet. So that's what it says. Nodes get an IP address from the Azure virtual network subnet, and then pods receive an IP address from logically different address space to the Azure virtual machine network. And these addresses are netted so that pods can reach to the resource on the Azure network. What it means is that, let's suppose here, so node 1 is part of one particular subnet overall from this particular virtual network. So you have a virtual network which is 192.168.0.0 CIDR 16. In that, you will be creating some subnets. In each of these subnets are these nodes. So 192.168.1.4 8/24 is one subnet here. And second machine will also be part of this subnet. And the pods that they give IP, that IPs are netted here. And as Microsoft Azure handle this, how this pod is going to talk to this pod here is via the NAT address. So this pod will do the network address translation, connect via the subnet, and go back to this machine here on the node port now, or sorry, this IP address. And from here, it's going to connect to these pod netted ports. So that's what is for the basic networking. Now, if you're deploying on the production kind of a network or production environment, then basic networking is not the right method. You can then have a advanced networking, and in advanced networking, what happens is each pod will get a separate IP from the subnet of the virtual network to which these pods belong to. What does it mean? I'll explain that in a minute. Let me repeat one, or I'll explain that with the diagram. But in advanced networking, it uses Azure Container Network Interface, or CNI, which is Container Networking Interface plugin with Microsoft Azure in advanced networking, where every pod get an IP address from the subnet and can be accessed directly. So this is the advanced networking diagram. So I have a virtual network, which is, for example, something similar to 192.168.0.0/16. So there'll be an IP address from this subnet, which is 192.168.0.0 CIDR 16. There'll be IP address for this pod 1, pod 2, pod 3, node 1, node 2, pod these three pods, and so on. So this pod can talk directly to this pod without the need of having a bridge kind of a network, because these pods are on same subnet. So that's advanced networking in Microsoft Azure. So there are two types of networking you can define in Azure Kubernetes. One is basic networking that uses KubeNet, or advanced networking, which uses CNI, which is Container Network Interface. Now, this Ingress controller is you have a network or application layer intelligence where a request comes for a particular URL, for example, myapp.blog. And based on this, because you have a blog, it's going to go to a service that's serving blog related request. Or if you have a store, then based on this store, this will serve to the service which will serving the store type of service. And then the service which we saw earlier in this lesson, it will forward request to the pod. So the Ingress controller handle request at a layer 7 of network OSI model that we saw earlier here. On this diagram here, this layer 7, which is application tier. Or You can put a load balancer type of service as well. However, if you put a load balancer type of service here, it doesn't understand the configuration, like it doesn't understand the application logic like /blog or /store. You can only forward that request load balancer to one of the service here. So you may have to then define multiple load balancers. So this is Ingress controller. Now there is a app gateway. This is a service in Microsoft Azure, which basically runs kind of a load balancer, but at the application layer, which is layer 7 in that OSI network model. So you can configure the application gateway as an Ingress controller on Microsoft Azure Kubernetes Service. So that Ingress controller, which is application gateway itself, will run inside a Kubernetes or in a Docker or container, inside a container within as one of the pods in the Kubernetes cluster. So your application, you are putting a Ingress controller of type application gateway in front of or with any request coming to the Kubernetes cluster. So let me go back to this Ingress controller, which I was saying earlier. So as I said, you will have an Ingress controller, which is the Azure load balancer or as your Ingress controller, which will listen for HTTP request or HTTPS request, and based on, you can define a rule and say if it's store, go to this service. And we have already defined the service, and service will define and say point request to the pods through the labels that we defined earlier. And similarly, other type of, like you say, another rule may be say rest everything, forward it to service A, and that service A via the node port will forward it to these two pods or a collection of pods. So if you look at Azure Kubernetes Networking, you have an internal traffic that can pod to pod communication, any communication within the cluster. It can go to the cluster IP or the service that we define, and that can forward request to the pod. So just to do a quick recap on the networking, and again, you might have to watch this networking one more time. So just to do a quick recap, the Kubernetes network addresses the challenges or serves the purpose of or defines how container to container communication going to happen within a pod. So let's suppose you have two containers within a pod. So let's suppose you have two containers within this pod. Pod A, in that you have container 1 and container 2. That container 1 and container 2 will be able to type or talk to each other just by typing localhost address, which is 127.0.0.1. If these two containers are in different pod, then they will be talking via the pod IP address, pod to pod communication. So you have pod to pod communication. You also have pod to service communication, which means if this pod wants to talk to this another pod, it'll go via the service. But it doesn't need any further configuration. They can talk to each other. If you have a request coming from outside the or from the internet, then it will be communicating using service via the node port. So these are the requirements. And as I said, each pod in Kubernetes have its own IP address. So the communication between from client to the application running on pods is happened via the service, and service has a label. So in use define label and say the service will be serving all the pods with these two labels, for example, and then you're running these pods with that label. Now, this label you define, you can say one label or 5 labels or 2 labels, depending on that. And as long as pod has those labels, the service will forward a request to that. Now, there are 4 different types of services: cluster IP, within cluster communication, node port, which is from request coming from outside the cluster. Then you can also define a load balancer for requests coming outside the cluster. Or inside the cluster, as long as you want to route them via the load balancer, or for external name, which is pointing to a DNS entry, you want to send requests through that CNAME specific entry. So the node port is going to be more common, load balancer or node port. For cluster communication within cluster members, cluster IP. Then when you're defining, you define a service, and this is how you define the service, which we saw in YAML file. We looked at the cluster IP as well as the node port communication, how this node port communication happens. And then Azure Kubernetes, there are 2 types of networking: basic networking and advanced networking. And then you have an Ingress controller. Now head on to the next lesson where we're going to look at storage, and there's something called as persistent volume. That persistent volume, basically the disk spaces that you create, and then you allocate these volumes to the pods using something called as claims or persistent volume claim or PVC we call. And that's how then application or using or containers running on inside the pod can leverage or use this volume. So, and how these two, what are the two different type of storage options in Azure Kubernetes? We'll see it in the next lesson.
So guys, this was a clip taken from our step-by-step comprehensive program that has 16 modules, 60 plus lessons, 35 plus hands-on labs, CV and exam preparation, and the most important, on job support. So this comprehensive program is specially curated for you so that you can be from beginners to a master, and you can master every skill set that has been required here. And if you're somebody who would want to start off their career in the domain, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get you higher paid jobs. And don't you worry, this interactive session will help you in gaining the understanding of why learn containers and Kubernetes, what is Docker container architecture. We'll be discussing about pod with highly available and scalable applications on Kubernetes. We'll be having demo so that you can perform really, really well. And now if I'm talking about that, what special do we offer? We have the comprehensive learning path for Docker and certified Kubernetes administrator course. So in week 1, we'll be talking about microservices and Docker. Week 2 is about Docker, networking, storage, and app stack. Week 3 is about Kubernetes architecture and installation. In week 4, we discuss about security, troubleshooting, and high availability. Week 5 is about networking, that includes all the networking policies, securities, context, and whatnot. And one thing that I have to mention here is that with every session, we have labs so that you can practice whatever is being discussed in the class, and this give you a knack over everybody because you will have the practical knowledge. Coming to week 6, we are talking about deploying of daemon processes and whatnot. Week 7 is about application stack. Week 8, we talk about advanced networking, of course, followed by some different laboratory sessions. And in week 9th and 10th, we are completely focusing on your certification preparation. That includes project work. Then we have certification practice part 1 and certification practice part 2 as well. And in week 11th and 12th, this week is completely dedicated for your CV preparation and your project work, because project work is something that is going to help you with all your exams and of course interviews as well. And now talking about the hands-on labs, and as you can see on the screen, we have almost every topic covered. So with every topic, you'll have a fine-grained understanding of whatever topics we are covering, and each topic you can have a practical knowledge that is going to help you in your examination and of course in your jobs. We also have sample exam papers in PDF format. And here you can definitely see on the screen that what kind of questions we have, and these questions are going to make you prepared for your exam and your interviews. So if you really want to have a basic, and if you really want to see what all we're going to cover, then we have this free class where we'll be talking about why learn Docker and Kubernetes and Docker containers architecture, image and containers and whatnot. So if you want to register for this free class, then just have to log on to K21Academy.com/K8S02. You'll be seeing this kind of interface. Just click on book your free seat now. Select an event date, add your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface where you just have to save this link on the extreme right, add it to your calendars, and I will see you in the free class. Till then, keep learning.